Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO here at NextGen Agri International, where we help livestock managers get the best out of their stock. Before we get started, thank you to our two fantastic sponsors for continuing to sponsor this podcast. MSD Animal Health is perhaps better known as Cooper's Animal Health in Australia and for their Allflex range across the world, with a comprehensive suite of animal health and management products. Honega is a one-stop shop for wool harvesting and animal fibre removal. The Honega team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. Great to have you listening along. You're with Ferg as usual. This week on the show, we feature John McEwan. John's sort of the grandfather of genetics in New Zealand. He has been heavily involved in the whole genomics, revolution we've seen over the last couple of decades, and he's a researcher, been based at AgResearch for a long time, sort of semi-retired or meant to be retired, but turns up at work every day still, I think. But a great chat with John about all things genetics and genomics. Before we get into that, I just wanted to mention the latest article that we've put out, and it's one by Sophie again, who always writes some interesting work. This time, Sophie's challenging the popular mantra that if you're the smartest person in the room, you're in the wrong room. While that always sounds like good advice, Sophie argues it's missing the bigger picture about learning and connection, and covers her thoughts on that popular mantra. So be interested in your thoughts on Sophie's work. Another great article there to read along. Also wanted to mention our NextGen Angus muster that's coming up on the 10th of September. So if you're a young person out there working in the beef industry, it's a great opportunity to get together with your peers and also hear from some great speakers. There's more on that on the hub, or you can find that in the Angus newsletter, or if you just Google NextGen Angus muster, you'll find information about that. 10th of September, down in Victoria. Going to be a really, really great day. Looking forward to getting along to that. Righto, we'll get underway with this week's show with John McEwan. Welcome, John McEwan, to Head Shepherd.
Thanks, Mark.
Thanks for coming along, John. Yeah, and I guess the reason to have a chat was around you've been in genomics since before genomics was a thing, probably. And so, I guess just that time, that history of DNA as it started off, we all heard about, what were they, QDLs and all sorts of stuff back in the day, and obviously ended up in STIP chips. But I guess, maybe take us through a bit of the history about where DNA, or where the concept of using DNA in animal breeding started, and where we got to, I suppose. Well, that's a big question, but we'll have a chat about DNA generally. But where do we all start?
I sort of went through and did biochemistry and chemistry in the 70s, and DNA and sequencing of DNA was just starting to be thought of at that time. And in the 80s, there was quite a bit of emphasis on, obviously, genetic improvement. If we're talking about sheep in New Zealand, emphasis on genetic improvement. But the evaluation systems really didn't even allow across-flock, across-year evaluations. So we had these group breeding schemes where basically people would put their best animals into nuclei and then distribute brands out. And so that was going okay. But the real problem in New Zealand at that time was the sheep were too small for the carcass trade, and the reproduction rates were pretty abysmal as well. And so those were the two big challenges. And obviously, for breeding for increased carcass weight, you just need to measure the animals. So that wasn't too much of a problem. Yeah. But the reproduction one was a big problem, because you couldn't just look at a ram lamb and say, well, this is going to be a good one. So there was quite a lot. The early emphasis was on genomics, as we call it now, genomics to increase lamb production. And there was quite a lot of emphasis looking at either importing breeds that were more fecund and crossing them, or trying to find mutations that increased the number of lambs born. And people knew about Brawler and were working on Inverdale. So that drove most of the development through the 80s and 90s, right?
Just looking for major repro genes, like looking for Brawler and...
Yeah, major repro genes. Yeah. That was the rationale to get into genomics.
Yeah.
Find the mutation, so it would be a lot easier to introgress these major variants.
Yeah.
There were a bunch of other things going on, but really the biggie came along in the mid to late 80s, where frozen semen and AI came in, and sort of along with that was animal model blood evaluations in sheep, right? And it would be fair to say that in New Zealand there was a bit of a rocky start on that. So it was well accepted and it was taken up, but the evaluation side really struggled, right? And at that time, the government pulled out from supporting those genetic evaluations in sheep and beef, and the industry took quite a long time until we now had what became SIL and now beef and lamb New Zealand genetics. So genomics was for these reproductive major genes, but when BLUP came along, people began to realize that, hey, we can do DNA parentage, okay? And that had a really big impact, but not in the way that I think that people actually expected, right? So people had been trying to find major genes, but the actual outcome was DNA pedigrees, late 90s, early 2000s. And unlike a lot of countries overseas, DNA pedigrees really was taken up very well in New Zealand. And it was fortuitous. The key development wasn't actually the DNA genotyping. The key development was pregnancy scanning, right? Because people wanted to increase the number of lambs born. That meant you had to record it. We can do pregnancy scanning, and we can work out lamb survival with fetal aging and stuff like that as well. And bingo, you've saved yourself a lot of money because you save a lot of feed in the autumn because you don't have to have a lot of single cell mating groups, and you don't need to record as intensively at lambing. So that was really quite a big change, and it was coupled with BLUP, and it really lifted the rate of gain in the industry, probably from about the late 90s through to the mid 2000s, right? And then what came along after that was the central progeny test. So that was just basically making more of the advantages.
Yeah.
Right? But that's not genomic selection, right?
Yeah.
We had a few scarums along the way. So one of them probably that came up was that the Texels were imported and they had this major gene for muscling, and well, that variant and the Texels have been pretty widely distributed throughout the New Zealand genetics now, which is, if I understand it correctly, really didn't happen in Australia, as an example, but it came with that quite a few of the Texels actually had a variant that caused microphthalmia, or small eyeballs, and blindness. And this is an example of where the single gene thing really, really did work, because that problem was got on top of and essentially eliminated from New Zealand, but it would have caused a lot of problems if we hadn't actually had those tests around in the early 2000s. Yeah.
Because like all deleterious mutations are always, generally recessive, so you need to find the carriers that aren't obvious.
Yep. Yeah. So there we were now in the early to mid 2000s. The human genome had been just sequenced. People were talking about spending, they spent about $100 and something million US to sequence the cattle genome, and we were wondering, we got heavily involved in it because in part we knew that we needed it for sheep because the sheep industry wasn't going to fork out that type of money.
No.
But as it was, we learnt the cheap number 8 wire way, and in the late 2000s, so about 2007 to about 2009, we spent, I think it was $2 million, half of it from Australia, half of it from New Zealand, and a bit tossed in from America. And we not only sequenced the genome, but we got a 50K SNP chip out of it. The key, so here we are, basically 15 years ago now, and looking at genomic selection. And it took, to be fair, everybody knew pretty much based on looking at dairy cattle where the advantages were, but it's taken quite a long time to really get it implemented and to be well used. And I would have to say that we've come a long way, but there's still quite a lot of money being left on the table. So, the rate of genetic progress was okay, but pretty slow in before about 1995. It increased about 50 or 70%, and then it increased by about another 50% after the CPT came in. But we should be getting, another 50% on top of that with genomic selection. And there's still, there's certain pockets of the industry that are doing very well, but we still really need to get on top of it a bit more.
Yeah, for sure. And I guess that is probably both our reasons for getting us out of bed each day is to try and get that rate of genetic gain up. And genomics is the latest tool in that process that, well, one of the greatest things we've probably ever had to actually accelerate genetic gain, really. And I think if we do look, 15 years is not that long, I suppose. And so we have come a long way, but there's still plenty of room to go. I mean, that early gains were obviously made just through phenotypic selection mainly. When you said...
the truth is it was BLUP and across the CPT and across FLOT.
Yeah, so once you had pedigree, yeah.
Yeah, that really, really, really made a big difference, and it made a big difference in the traits that weren't, visually assessed. Yeah. So reproduction, a little bit on lamb survival, a bunch of the meat traits, those that's where the gains are. And some of those traits are still the ones where genomic selection can really help along as well. But genomic selection is, everybody's heard it numerous times, is if a trait is hard to measure, like fly strike, or it's measured late in life, like longevity, or it's sex limited, or it's got a low heritability, or it's expensive to measure, or it can only be measured after you killed the animal. All of those traits really, really benefit from genomic selection. And part of the problem is actually there's probably not enough animals measured for some of those traits, particularly things like facial eczema, feed intake, and even traits that everybody thinks they measure, like, say, lamb survival. If you could do just a bit better job in actually measuring the lamb survival itself, that this was a fetus and did it survive to weaning? Yeah. Just that, perhaps a little bit of thinking about whether you could get a little bit of extra advantage by including the weather in the genetic evaluation or things like that can make a huge difference in the program.
Yeah, and I think, obviously reproductive traits is what we tend to focus on because we know they link to profitability, particularly survival. But yeah, as you've just covered, it's the hardest one pretty hard to measure in the sense that, ideally you're in the paddock and actually see it born and then see that it's not there still, rather than, was it a misscanning or a wrong scanning or all that error. I guess that's the problem, and that's what we always talk about. All of this process is all about just reducing error. It's the error that's what kills genetic gain at the end of the day, and so the more error.
Well, you would have to, prior to DNA parentage, there was some people that were manually recording, and they're out in the paddocks and they were doing a really great job.
Yeah.
But if you actually did the DNA, some people were only making 4% parentage errors, but other ones were up around 25%.
Yeah.
And a lot of the data was, just the parentage, not even the lamb survival recording, was pretty dubious, to be blunt. And so we can go a lot further, but you've got to look back as well.
Yeah. I mean, obviously, you ran through the traits where genomics works well. Obviously, the other one is just being able to use those ram lambs with even traits that are going to be recorded at 6-7 months of age or whatever. Often you can already have genomics worked out which ones are going to at the top end for 12-month-old traits or whatever. So yeah, I guess that's one of the key ways we accelerate things is through young use.
Yeah, it would be really great if we could genotype a ram lamb and we had accuracies for the genomic breeding values that were in the 60 to 70% range.
Yeah.
Right?
Yeah.
Typically, at the minute, they would be probably quite low if you just use parentage for a lot of those traits.
Yeah.
Probably 20 to 30%. But with genomics at the minute, you're probably getting around 40 or 50%. But you've got to sell that message to the breeders and to the people that are buying the rams that, hey, these BVs here are actually pretty good. It's not going to technically increase the rate of genetic progress, but it would assist the shift to more genotyping and more trait recording. If those accuracies were there in bold, right? They're there in bold and for dairy cattle and everything else, so they should be there for sheep as well.
Yeah, I guess what we see, and I'm talking from a merino frontier, when we do get those sort of accuracies like mid-60s or whatever, often in ram lambs because of the size of the reference population in Oz. And I just feel like we're making a lot less mistakes than the ram lambs we're using when you've got a genomic breeding value or genomic informed breeding value compared to what we were when we were using mid-parent breeding values essentially. All that.
So that use of ram lambs is actually quite high in New Zealand.
Yeah.
But even a moderate increase in if the accuracies, breeding value accuracies, were a little bit better, even a modest shift in the average age of the sires can deliver quite large benefits.
Yeah.
So I think that is one area that needs looked at, and it's just convincing breeders that the accuracy of the breeding values is sufficient to take the punt.
Yeah. And I guess as we've gone on, we were characterising a lot more things in the animals, so there was a risk if you used it early and then it went and got daggy later on or something and you wouldn't have used it. The benefit of using it two-tooth is you've got time to see its faults, I suppose. But as we characterise these animals better and have more traits covered, then we know that we have more certainty around which animals to use because we can kind of predict all those other welfare traits and stuff as well as the meat traits or the repro traits.
I think that particularly for the things that people tended to use the drafting gate for, we'll call it fly strike, teeth, mouth, feet, udders, those things and a bit of structure. Yeah, there's definitely some value there because you can use independent culling levels, but having breeding values for those that everybody's happy with, foot rot is probably the classic example for merinos is great.
Yeah, it shifts it a lot. One common misconception I think out there in genomics is that it's identifying the genes that are linked to the traits, whereas it's essentially a really deep relationship matrix. It's not you don't know which gene is giving you more lambs or which combination of genes are giving more lambs. It's more about just knowing that an animal with this, animals that are closely related to this animal did this sort of reproductive rate. That's how its prediction capacity is formed.
Yeah, it's basically it's better using the information, the phenotypes that are collected on relatives. Yeah, and it's not so much in sheep, but in if you're in breeding fish or pine trees or something like that, is about half the potential genetic gain is sitting there. Is you've got say prawns, you might have 200,000 larvae from a male and female mating, and it's actually picking the best one amongst them.
Yeah.
As an example of where you can make gains. Yes.
They're massive. I had it quoted to me once how many tons of prawns one female prawn can produce. Some insane amount of. Anyway, I can't remember the numbers.
But the concept's definitely sitting there with sheep as well.
Yeah. The thing that's been, I guess, the next sort of iteration in this process is going from SNP chips to genotyping by sequencing. Is that kind of where the industry will end up, or that's just a way it could go?
Well, I think there's the sheep industry is actually in a pretty good spot, but so genotyping by sequencing or some variant of that it will be the future, right? But when it came along and started to be used widely about 10 or so years ago, what it actually did was pretty much halve the cost of genotyping with SNP chips, because it was a competing technology and it pretty much halved the cost, right? Because if that chip costs and that didn't decrease, the industry would have gone across to genotyping by sequencing.
Yeah.
And so a whole bunch of plant species, deer in New Zealand, dairy goats in New Zealand, a lot of the aquaculture species basically just went straight into genotyping by sequencing. There's a lot of people ask, well, how low could genomic selection, across to genomic selection go? If you look at it now, the actual cost of collecting a sample and extracting the DNA from the sample and everything else and the infrastructure around that is by far the majority of the costs.
Yeah.
The actual genotyping costs are actually relatively small. So I think the sheep industry got the benefits of genotyping by sequencing just because there was this competing technology there.
Yeah. So
but at some point, the sheep industry is going to have to face up to the fact, it's not necessarily next year, but, in 5 or 10 years' time, it probably will have to face up to the fact that it's going to have to shift technologies. And there will be some benefits when it does do that. Yeah.
To save using gigawatts of power on ChatGPT for everybody out there wondering what genotyping by sequencing is that in terms of those two technologies, is there a simple way of explaining how they differ and what they are?
Yes. So SNP chips, you do a bunch of work, find out where there's DNA variances, and you've got 3 billion base pairs. You find out where the variants are. You select about 50,000 of those evenly spaced across the genome, and you do assays that are very, very accurate for those 50,000, right? Genotyping by sequencing is the way that we do it, is you essentially chop up the DNA and select a consistent 1% of it and run it through the sequencer. And you get reads and you call those variants from the actual sequencing reads. So it's both a discovery platform and a genotyping platform in one. And really the really big benefit of it is you don't have to do a whole lot of preliminary work, and you essentially use the same method for whatever species.
Yeah.
So you don't have to say, I've got, only 55 sheep and, you just, there's some sheep, there's some deer, there's some prawns, there's some whatever. You just put them all together and you run them through the sequencer.
Yeah.
So it's got a whole lot of other procedural benefits as well. Is that clear enough, or I've missed?
No, that was good. That was good. That was
Yeah.
And I think the obviously we can't give a full biochemical lesson in a podcast, but good to know how they differ.
Yeah.
You mentioned earlier the money that's sitting on the table in genetic gain. In your mind, what are the kind of, if you could wave your magic wand and change the industry, what would that look like in terms of what you would change in structure, or what's measured, or how it's measured, or how much genotype is used, or what the perfect breeding program look like, or however you want to answer that, really?
Right. So money on the table. So I want to go back just briefly and talk about the industry itself. So it's not very commonly publicised, but as far as grass for sheep and beef farms, the evidence we've got is that grass production per hectare on sheep and beef farms probably hasn't increased for quite a long time. Or if there's any change, there's a bit of an argument about how much it's increased or decreased, actually.
Yeah.
So the sheep industry in New Zealand has done an amazing job, either on a per head basis or on a probably per kilogram of dry matter basis. Probably about 1% per year. Let's put it like that. That's in product per kilogram of grass grown, right?
Yeah.
And that has, in my opinion, has been due to genetics and then altered management to take advantage of those genetics, right? It's not just genetics, but almost, if the genetics wasn't there, you wouldn't be able to do the altered management to get the additional benefits.
Yeah.
Okay.
Yeah.
So how do we make the boat go faster? Well, you get what I mean, as we're actually talking about the productivity of the sheep industry in this case itself, right? And our major competitors are essentially pigs and chickens and beef, right? And pigs and chickens have got on top of this because they tend to measure a lot of other things that are important to increasing that productivity. So measuring feed intake, and probably doing a much better job in many cases around traits like disease resistance and stuff like that, but particularly feed efficiency. And in New Zealand, we tend to talk about methane emissions and stuff like that, right? The other thing is it's very much better integrated, vertically integrated. So how do we do it in the sheep industry? Well, I think that's really a discussion with the breeders, the industry itself, and the researchers. But the first thing off is the central progeny test provides links so that we can do this common evaluation. The size of that central progeny test, it doesn't necessarily all need to be just in the core. And what traits are measured would have to be the first thing off the mark. I think there could be a lot more measurements made on the central progeny test. And I would, dare I say it, I think the central progeny test in some shape or form should be bigger.
To build a bigger reference population, is it? Or
to provide better genetic links
between
and to measure more traits that are going to make the boat go faster.
Yeah, and I think one thing that I think the key difference between Australia and New Zealand is the amount of use of AI. So the amount of, I guess, how many people actually create their own linkage by using artificial insemination, really quite frequent and quite widespread in Australia, whereas way less so here, and therefore a much higher requirement for a CPT here, because the flocks aren't naturally linked as well as what they are in Australia.
I think that's you've touched on the second point, but it's actually the first point as well. So in Australia, we have to admit it's slightly bigger than New Zealand.
There's a lot of nothing in the middle there.
Yeah. So chucking a ram on the back of a ute to go to your mate, so it can be used on two properties, is a little bit more difficult. But underneath it, there is a bunch of animal health reasons that are very present in Australia that are ignored in New Zealand, or less so in New Zealand.
Yeah.
So yes, there could be a lot more use of AI, and that would provide a distinct lift.
Yeah.
But that actually gets back to the CPT itself and the accuracy of the breeding values of these better animals. So that is definitely the second arrow in the quiver, if you get what I mean, as well. Yeah. And those are at the breeding structure level. Okay, the breeding structure level within the breeders' flocks. I'm pretty certain that if you go and look at what they're measuring, there's a bunch of traits that don't cost very much to measure, but would be really, really useful if a greater proportion of the breeders measure them. Things like DAGs, things like adult ewe weight, things like body condition score, thinking carefully about how you measure lamb survival, all just the little things that would help, right?
Couldn't endorse those four things stronger.
Well, that's your day job, I think, isn't it? And, just the breeding structure itself, right? But outside of that, there needs to be, clarity to the commercial ram buyer that, this is how much extra money or how much I'm going to save by buying this ram versus the one that I've actually got on my property. So I think there's a bit of helping demand as well would be really useful. That marketplace for farmer demand for better rams, and for that they need to know how well their existing rams stack up, and there are a lot of other things, because I'm was a researcher. There are a lot of other things, that are 10 to 15 years down the track that we probably should be doing as well. And for me, if we had expanded CPT and stuff like that, and it was on at least part of it was on a harder property, is things like, well, it would be really nice to have GPS on all of them and accelerometers on them, and so we could possibly measure feed intake in a grazing situation, and a more intensive measurements, so that we could get more information to feedback through the system. The ideal scenario is, the weather looks bad, and she's gone and decided to lamb under the tree rather than beside the edge of the creek, the usual thing
on top of the hill or whatever. Exactly.
Yes.
And I think that there's a lot of merit in that. I think we were just met up with some colleagues from Australia in the last couple of days, and we were having a giggle about lifetime wool, which became lifetime ewe management in Australia, which it was only an accident that we ended up having twins in that experiment at all, because we didn't have enough singles because the AI didn't work as well. And yet that's been the best outcome of that entire project. It was the fact that we did have twins, and then that's been a key part of that whole project. And so my point there is that I feel like we've got to measure lots of stuff, even if we don't know why sometimes, or even if it's only a loose hypothesis, because once you've got the data, you can find the relationships. But if you haven't got the data, you've got nothing to find. And it's quite...
Yeah, and obviously, we haven't discussed it, but obviously in the breeding for lower methane space, there's a lot of emphasis on trying to get proxies, like sequencing the rumen microbiome or if they're milking animals, looking at the fatty acid composition or whatever to predict methane.
Yeah.
But the truth is a lot of those measurements, we're not just looking at that. We're going, oh, well, could we use it over here? We might want feed efficiency. Can we get a proxy over there? Or does this affect the eating quality of the meat or whatever else?
Yeah.
It's not just, there's going to be something that might happen. It's also, let's take the advantage to try and improve those other traits as well.
Yeah, exactly. Yeah, and I feel like to one extent, quantitative genetics allows you just to make gain in a trait and have no idea why. You're not sure what's actually happening in the physiology of the animal. But then understanding part of that physiology helps you, helps work out what might go wrong or what might go right from that change. So it's always but these are very expensive things to do often. The working out, whereas just selecting for the outcome can be expensive, but it's a lot cheaper than finding out what's happening, how it's happening.
Yeah. I think one of the other things is if you're looking forward into the future, you get what I mean? What I am sure that you could increase the rate of genetic gain and by 50% from what it is currently, using most of the tools now on the table in New Zealand. And like I said, it looks like for productivity increases, this has been the key determinant for the sheep industry in New Zealand for the last 20 or so years. Not to say that we shouldn't take the foot off the throat of the plant breeders or anybody else, but, we should do stuff. I do look at the sort of more basic research that's being done around the world in these industries, and I would have to say that doing this will probably allow us to identify the key genes that are involved, and possibly in sheep, but probably from other species as well, how to modify those genes so that they could produce things better. And it's pretty obvious to me that in sheep, at least, the Chinese are doing a lot of work in this space.
So you're now talking gene editing?
I'm now talking gene editing.
Yeah.
Yes.
Yeah.
But the thing here is that there's got to be a lot of upfront investment for a long period of time.
Yeah.
But if we don't do it, other countries are going to do it.
Yeah. Yeah, so that's taking gene. I mean, obviously there's immediate benefits right now from gene editing for horn, pole or stuff that we know. But then, if you start doing the work and work out what's causative for what, and then, obviously then it becomes even a lot more powerful if you can start impacting quantitative traits rather than just the yes/no traits.
Well, yeah, the obvious thing is that in the low bit is that we've got a bunch of variants, but the real issue is the time taken to introgress those variants into the animals that we're reasonably comfortable with.
Yeah.
I am sure that if you had a bunch of changes that could give you a short tail and a hair sheep, and you could introduce it to some of the highly FE-resistant animals that we've already bred, and you could do it in one generation, you get what I mean, rather than doing the backcrossing program over 15 years.
I reckon we could sell that. Yeah.
Yeah. From both an animal ethics as well as production scenario.
And this is probably, the last 3 or whatever the number of years, it's a classic case where if had you been able to do that, there'd be no, you just take the wool off sheep without having any drop off in productivity or change in welfare or any other outcome that some people have seen. That it would have been that's exceptionally powerful, and I'm sure that's someone's working on it somewhere, and you're saying it's in China. So
oh well, I've been in China, and I've walked into sheds that the publications are coming out, and yes, there's this gene edit here, and there's that gene edit there, and you walk down and there's the pens, and it's not just one. There's four or five of them.
Yeah, right. Interesting space. That's been great, John. I didn't give you any lead time on this question, but one thing we like to ask people is who's been the best, had the most influence on them as in their careers. Have you had any individuals that have sort of influenced your career over the time that you've had a great opportunity to learn from?
I've been very lucky. There's actually been quite a few. There was a guy called Limbo Thompson, who was a farm advisor that was my first boss. I've worked with at various times. Peter Fennessy was my boss. George Davis was my boss. On the genetics side, there was Neil Clark, who headed the genetics section at Ruakura for many years. And I've been very lucky to work with a bunch of the staff that he had for just about my entire career.
Yeah, right.
Alan Crawford had a major impact as well. He was more on the molecular side.
Yeah.
And I've been very, very, very lucky to work with probably one of the best statisticians in New Zealand, with Ken Dodds, for many years. So, and there's a whole bunch of other people that are slightly younger than me that I've been very lucky to work with as well.
Yeah.
But those are the 4 or 5 there are probably some of the key people. I've been pretty lucky as well, working with a bunch of people from overseas.
Yeah.
People like Tim Smith in the US and Hutton Noddy in Australia. That was mainly around the methane side of things as well. Yeah, been pretty lucky. But there's a whole bunch of them as well. Yeah.
It's a measure of your base intelligence if you can have a chat with Hutton Noddy and keep up with him. He loses me in about 10 seconds.
He nudged me on the straight and narrow on the methane pathway, I would have to say.
Yeah, right. Excellent. Good. Yeah. And the last question we asked, which is a bit tough without notice, but is what's the last thing you changed your mind about?
Last thing I changed my mind, yes. Well, you change your mind. That's science, right?
Yeah.
That is science.
Yeah.
Science is when you have evidence that you change your mind about it.
Yeah.
For me, I have to regularly change my mind when new evidence comes in.
Yeah.
And the last couple of months, probably there'll be at some stage a mutation will be published. A sheep mutation will be published, not relevant to New Zealand, and we will have to reflect on how we went about doing it.
Yeah, right.
Because we probably lost a year by not doing something that I should have done.
Yeah, right.
And probably the other one that has been exercising me, and these are pretty trivial things, but it just shows you the process, is going back and reviewing the evidence around what's causing dagginess.
Oh.
Is it bare tails or short tails, or is it different wool and a change in the internal digestion of the animal? Which is more important? And probably the evidence it's actually the wool type and the internal digestion of the animal, to me, not how bare the tail is.
Yeah, well, it's nothing. I haven't read literature, but I would agree with that.
These are probably reasonably trivial examples, but we do have to regularly change stream, and the biggest change stream for many of the molecular people was to give up the concept with the technology that was available at the time that you were going to do everything with single genes and going to have to use genomic selection.
Yeah.
Right.
Yeah.
That, and in my career, that would be probably the biggest change I've seen.
Yeah. Yeah. and lots of benefits from that change. So, yeah. Excellent, John. Really appreciate your time having a chat with us. Obviously a stalwart in the genomics game, been there through the whole development and continuing. You keep saying you're retired, but retired back to 5 days a week. So,
something like that. No, I'm in the great position that I'm picking and choosing, and I'm picking and choosing less.
Yeah. Oh, excellent. That's good. Good to hear you getting some spell. Excellent. Well, yeah, I really appreciate your time.
No, thank you.
Thanks. Thanks again to Heinegger, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Thank you to MNSD Animal Health and Norflex Livestock Intelligence. They offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. We thank both of these companies for their ongoing support of the Head Shepherd podcast.